The concept behind Klingmagon is to have an instrument clinging to the outside of the house and transfer power wirelessly through the window or the clear window of the door to the instrument outside so that I don't have to run wires through the walls. My initial concept was to use these Qi charger type pucks that can generate power and to receive the power through a wireless receiver, which would normally be used on a cell phone. I even tried it with a very fancy coil which is supposed to receive power from a charger. But these things are only really sensitive a few millimeters in height, and these things need some kind of communication to keep them turned on. So that really didn't work out. So I ended up using my own design. So this is a coil on a printed circuit board, and it has a little receiving circuit here, which is a charge pump to increase the voltage that this thing receives. And of course it needs a transmitter, which is this module. So we have a little power oscillator here which can be tuned with this potentiometer to the correct frequency. These things are actually going to be tuned at a resonant frequency so that we get the maximum power transfer, and we can just separate them through the window and receive power across the way. So I'm going to do a little bit of a demonstration of that right now. This cable is just connected up to a USB power brick, and it's oscillating here. I have to turn it on, and you can see even when it's beside here, it's receiving a little bit of power. But there's a little LED, I don't know if you can see it, that turns on when there's power. So this thing is lighting up the LED this far apart. So it's receiving enough power to turn on that LED from this far away, which is several inches. So that's pretty good. That's a good indicator that I could get some power to run my instrumentation through this power transfer. It's actually an air core transformer, but it's oscillating at about 130 kilohertz, and it's doing a good job of getting power across the gap. Now, of course, I need to get that power up to a regulated voltage, so I have a little DC converter here which takes input from this coil and outputs a regulated 5 volts on a USB connector. And of course we need some instrumentation to run, so here we have a little temperature sensor connected up to an Arduino, which is also running an LCD. And we'll be able to see the display of this LCD through the window. So this thing will be completely outside the window, and just measuring the temperature and displaying it on the display, and powered through the window, so no wires going through the window. So let's connect that up. This guy connects in here, and he's powered from this one. I want to keep that separated until we get it all connected. So now we have a power supply and a remote instrument. Actually, let's do that here so you can see what it's displaying. Maybe I should get it up a little closer. That's really not a good angle to see it. Here we go. So Klingmagon Temperature 19 degrees Celsius. And that's really mostly what it does. So I can grab this. This thing takes quite a while to respond to the temperature of my hand. They're starting to go up. 20 degrees, 21, 22. So that's how it works as far as transferring the power and displaying an external instrument through the window. It even has enough power, of course, to light this LED on the Arduino. Now, I'll just try and prove exactly how far we can get power across. So, this is a hockey puck, 1 inch thick. And here's another one. It's 1 inch thick. You can see it's thick. And if we put that across, you can see that it works fine with a 1 inch separation, so that'll go through any window. I can actually put a window there. Let's do that. So here's a piece of glass, and let's put some spacers so that we can get an inch between the pieces of glass. So here's another piece of glass, and there's an inch between these two pieces of glass. And now if we put the power receiver on top, it's receiving lots of power. The temperature's displaying at 21 degrees. So one of the reasons I wanted to call it a Klingmagon is that this thing has to attach to the outside of a window, and I would like to do that with magnets. So let's just see if we can show that. For now, I'm just going to use a single little magnet, but I want to increase the friction of everything so that it doesn't slide off the window. So I'm going to put a piece of rubber band across this thing and one on the other side. That's just to increase the friction so that the magnets don't slide off. We've got one. Let's put some separation between the glasses. So this is just a piece of foam rubber. Let's put another window there, just for the heck of it. So we've got two pieces of glass and some foam. I'll have to see where that magnet lines up with a magnet on the bottom. So there we have a magnet on each side, and you can see that it hangs in there no problem. It's just sandwiched in there. I can put more magnets if I need them, and I can get a little bit more distance between them. But that's the idea for the Klingmagon. So it'll just attach to the window through magnets and power through these coils. So kind of a neat concept to get power through a window without wires, and attach it without screws and nails and glue and all kinds of stuff. We'll just use magnets.